Let us discuss nomenclature of coordination compounds. And as you know, in the nomenclature of coordination compounds, we always name the cation first. And if the cation is complex, then you have to arrange the ligands alphabetically using a prefix di, tri, tetra, etc. And then you have to name the metal atom followed by its oxidation state in Roman numerals. And in the end, you have to name the anion. And these rules we have already discussed. Now, we will discuss some more examples of nomenclature of coordination compounds. Now, this is our first example. It is a complex of iron FeH2O whole 5 NO SO4. Now, this is an example of a cation complex, and this is the formula of the Brown ring. And this is the formula of the Brown ring for the nitrate ion. And this is one example where NO is present as a positive ligand called nitrosonium. Now, its IUPAC name is penta-aqua nitrosonium iron 1 sulfate. Now, oxidation state of iron in this complex is 1. So, iron 1, then we write the name of the anion called sulfate. Now, it is very rare to find iron in the +1 oxidation state, and as a result this complex is very unstable and the Brown ring decomposes as soon as we shake the test tube. Now, second example is this. It is a cobalt NH3 whole twice, En whole twice, and the whole twice and SO4 thrice. Now, this is suppose the example given of coordination compound. Now, in this case, first of all you have to identify what is your cationic part and what is your anionic part. So, we write them separately. Now, this is the cationic part. Cationic part is carrying a charge of 3 positive and our anion is SO4 2 negative. So, we name the cation first. There are 2 different ligands present, arrange them alphabetically. So, we write diamine with a double M, then we write bis ethane 1, 2 diamine, then we name the metal atom cobalt followed by its oxidation state in Roman numerals 3, and then we name the anion called sulfate. Now, we take some examples of coordination compounds where the metal shows 0 and a negative oxidation states. Now, this is an example. It is a complex of nickel NiCO whole 4, and carbon monoxide is present as a carbonyl, which is the neutral ligand. So, its name is tetracarbonyl. Then we write the name of the metal nickel and followed by its oxidation state 0. Now, fourth example is, this is called CO. It is a complex of cobalt CO whole 4 and -1. Now, this is an anion complex, and if you remember, whenever the anion is complex, then the metal ends in ATE. So, name the ligands first, or we arrange the ligands first. It is called tetracarbonyl, then we write cobalt as a cobaltate followed by its oxidation state, that is -1. So, there are some examples where the metal shows 0 and the negative oxidation states. We will discuss some more examples now. And the fifth example is this. This is called sodium nitroprusside, Na2 FeCN whole 5 NO. Its common name is sodium nitroprusside. So it is used in the detection of sulfide ions. This is also an example where the NO is present as a positive ligand, nitrosonium. IUPAC name is sodium pentacyanido nitrosonium, and then we write ferrite because iron is present in the anionic complex, so it ends in ATE, ferrite, and followed by its oxidation state, that is 2. And this is an example of a Wilkinson's catalyst. And Wilkinson's catalyst is a complex of rhodium. And the formula of this complex is RHCl PPH3 whole thrice, and in this case this first P stands for phosphorus, and this pH stands for the phenyl ring. We know the name of this molecule. This is called pH3. Its name is called phosphine. It is a neutral molecule but has a lone pair of electron present on phosphorus. When you replace all these 3 hydrogens of phosphine by a phenyl ring, then it is called triphenyl phosphine. Triphenyl phosphine. This triphenyl phosphine is also a neutral ligand, but in the rhodium complex there are 3 molecules of triphenyl phosphine present. So since the name of the ligand already includes tri, so we cannot use tri again as a prefix, so we have to use a prefix called tris. So its name is chlorido. We write tris. Then in the bracket we write triphenyl phosphine, and then we write name of the metal called rhodium, followed by its oxidation state, that is 1. So this is the IUPAC name of Wilkinson's catalyst, and this Wilkinson's catalyst is used in the hydrogenation of alkenes. Now we take one last example in this. If the formula is given, how do you write the IUPAC nomenclature? Now this is a complex of nickel. It's called K2 Ni OH whole 4. Now this is again an example of an anion complex, so nickel has to be named as a nickelate. So we write the IUPAC name of this complex as potassium, then we write tetrahydroxido, we write nickelate, and followed by its oxidation state, that is 2. So chemical formula from the name given. Now when you write the chemical formula, you first write the cationic part. So first we write the cationic part, and if the cationic part is complex, so in the square bracket first you write the symbol of the metal atom, then you arrange the ligands alphabetically, then close this bracket, then you write the anionic part. Write anionic part to balance the charge on the cation. Now this is the example given. First example is this. It's given hexa aqua platinum 4 chloride. Suppose this is the example given. Now we first write the cationic part. It's a hexa aqua platinum. So this is our cationic part, and chloride is the anionic part. So when you are writing the cationic part, you start with a square bracket, write the symbol of this platinum Pt, and in this case we have only one type of ligand present, that is aqua H2O, and 6 H2O ligands present. So we write H2O whole 6, and then we close the square bracket, and then you write the charge on this cationic part. Now since water is a neutral molecule, whatever is the oxidation state of platinum, that is a charge on the complex, that is a 4 positive. Now chlorine is present as a chloride anion, and chloride is Cl negative, it's a -1. Then you balance the charge like this. Write the formula of the coordination compound as Pt H2O whole 6 and Cl4. So this is the formula of this coordination compound hexa aqua platinum 4 chloride. Now we take one more example. Is given tetraamine dichlorido chromium 3 chloride. So again this is our cationic part, and chloride is the anionic part. So in the cationic part we start with chromium Cr, then arrange the ligands alphabetically, is a tetraamine. So NH3 whole 4, Cl2, and then we write the charge on the complex as X positive. We don't know what is the charge on this complex, so we assume the charge on the cation is X. So our aim is to find this X first. Now chromium oxidation state is given, it's a +3, ammonia is neutral, so it is 0, and chlorine carries a charge of negative -1, so it is a 2 into -1 equals to X. So X is equal to +1, it means charge on the complex is +1. So my cationic part is this Cr NH3 whole 4 Cl2 carrying a charge of +1, and the anion is Cl negative. So the coordination compound chemical formula is Cr NH3 whole 4 Cl2 and Cl. This is the formula of this coordination compound tetraamine dichlorido chromium 3 chloride. Now we take next example. Now question is write chemical formula of is iron 3 hexacyanido ferret 2. So in this case, iron 3 is our cationic part and hexacyanide is our anionic part. So we write the cation first. Our cation is Fe with the charge 3 positive, and our anionic part is this. Whichever part is complex, you always write the symbol of the metal first, and then you arrange the ligands alphabetically. So we write Fe, then followed by Cn whole 6, and suppose the charge on the anion is X. So again our aim is to find the charge on the anion X. Now in this anionic part, iron is given in the oxidation state +2. So we write +2. Cyanide is carrying a charge of -1. So 6 into -1 equals to X. So charge on this anion is -4. So we write the cationic part Fe3 positive and anion is FeCN whole 6, 4 negative. Then you balance the charges using this crisscross method. So the formula of the coordination compound is this: Fe4, FeCN whole 6 with a subscript 3. So this is our coordination compound. We take one more example. Now suppose you are given this, write chemical formula of potassium trioxalato chromate 3. Now this is the name of the coordination compound given. So potassium is our cationic part and trioxalato chromate is the anionic part. So we write potassium K and K with a charge of +1. Now trioxalato chromate. So we write chromium, oxalato is C2O4, there are 3 oxalato, and suppose the charge on the complex anion is X. So our aim is to find the X first. Now chromium is in the +3, oxalate is -2, so 3 into -2 is equal to X. So X is equal to -3, it means this anion is carrying a charge of 3 negative. So the final chemical formula of this coordination compound is K3 Cr C2O4 whole thrice this. This is the final chemical formula of this coordination compound. So this is about the nomenclature. If the formula is given, you should know how to name the coordination compound, and if the name is given, you should know how to write the chemical formula. So this is all about the nomenclature of coordination compounds.